Hello everyone, welcome back. We're going to do some notes over 2.4 symmetry. So this is all going to be algebraic tests of symmetry. When you're looking at a graph, hopefully you can tell if something is symmetric to the x, the y axis, or the origin just by looking to see, can I fold over the x-axis, can I fold over the y-axis, or can I rotate about the origin, and will everything line up? So that being able to look at it visually, hopefully we can see, but algebraically, there's some things we can do to test for that. So if we're going to test for symmetry with respect to the x-axis, we're going to replace y with negative y, and if everything is the same, so if you do that and you simplify and you get back the same equation that was originally given to you, so I'm just going to say all the same, then your equation or your graph is symmetric to the x-axis. To test for the y-axis, you're going to replace x with negative x. And again, if you do that and you simplify and everything comes back exactly the same, then you are symmetric to the y-axis. And then to test for symmetry to the origin, you've got to do both. So you're going to replace y with negative y and x with negative x. If you get everything back the same, I'm also going to say or all different, then you are symmetric to the origin. And you'll see an example of that when we go through it. But you have to do both when you're testing for the origin. Okay, so let's go ahead and take a look at a couple examples of these. So we'll test for symmetry on all, the x-axis, the y-axis, and the origin for y equals x squared plus 2. So we're going to go ahead and test the x-axis first. And for the x-axis, we replace y with negative y. So this becomes a negative y equals x squared plus 2. Now to simplify, there's nothing really I can simplify. I can take away those parentheses because there's nothing I can do with that. And this guy is not exactly the same as the original, so we are not symmetric to the x-axis. Okay, let's test the y-axis. So we're going to replace x with negative x. Okay, now simplifying this, it's still going to be y equals, now negative x squared is negative x times negative x. So I'm going to just write that out so we can see that. Remember, to square means to multiply by itself. Now if I actually multiply that, that's going to give me a positive x squared plus 2. That is exactly the same as our original equation up here. Everything's identical, so yes, this quadratic or this parabola is symmetric to the y-axis. We could put a line at the y-axis, fold over it, and everything would lie on top of each other. All right, testing for the origin. We have to do both. So we're going to replace y with negative y and x with negative x. Simplifying what we can, this is going to be negative y equals, we already did that simplification in red, it becomes positive x squared plus 2. When I look at that equation underlined in red, negative y, positive y, those do not match. The x squareds match, the plus 2's match. So it's not all the same and it's not all different. So this is not symmetric to the origin. Okay, take another look at an example like that. So we're going to test for x squared plus y to the 4th equaling 5. So we'll test x-axis first. For x-axis, we replace y with negative y. Okay, simplifying what we can. Now, negative y to the 4th, I could write it as negative y times negative y times negative y times negative y. But I want you guys to start thinking about what even exponents and what odd exponents do to that negative. So negative raised to an even power, negative raised to the 4th will always come back positive. A negative raised to an odd will always come back negative. If you need to write that all out to see it, please feel free. So when I look at this guy back to the original, everything is exactly the same. So yes, this is symmetric to the x-axis. All right, testing the y-axis. Replace x with negative x. Okay, so that negative is being squared, which would make him positive. So everything's identical to the guy that's underlined in black. So yes, this is symmetric to the y-axis. And then our last test is for the origin. For the origin, we replace both of them. So this will be a negative x squared plus negative y to the fourth equals 5. Okay, that negative squared will come back as a positive x squared. That negative to the fourth will come back as positive y to the fourth equals 5. Now everything is identical in this one, back to the guy in the black. So yes, this is symmetric to the origin as well. So it's symmetric to everything. Okay, so even and odd functions, an even function is symmetric to the y-axis. And then an odd function is symmetric to the origin. I'm going to leave these two examples for us to do in class, but we're going to be doing the exact same thing. So when we're testing for symmetry to the y-axis, plug in negative x. And when we're testing symmetry to the origin, replace both. So negative x to x and negative y to y. If we get back the same things, then we know there's symmetry there. But we'll save those for in class. So example 3, we'll do those together. All right, thank you guys.